We're surrounded by smart this and smart that, but have you ever stopped to wonder what really makes an object smart? Today, we're going to unpack the key technologies that power the whole show, the stuff that lets the physical world connect to the digital one. This is the Internet of Things. So think about this for a second. How does a farm, a huge one, know exactly when to water its crops without a single person even there? And yeah, that might sound a little like sci-fi, but it's happening right now. It really gets to the core of what we're talking about today, creating systems that can basically sense, think, and act all on their own. So how on earth does it work? Right, this is the big promise of what we call the Internet of Things, or IoT for short. And it's so much bigger than just smart farms. We're talking about factories that can literally predict when a machine is about to break down and get it fixed before it happens. Or roadways that automatically reroute traffic to prevent jams. It's this vision of a world where our physical reality and the digital world are just completely intertwined. Okay, so to really get how all this works, we need to start with the basics. First up, what is the IoT really? And when did this whole revolution even kick off? So, when you boil it all down, the Internet of Things is really just a huge network of physical objects. And I mean everything, from the thermostat on your wall to a massive jet engine. The key is that they're all embedded with little sensors and software. The main goal? It's actually pretty simple, but it's a big deal. To connect the unconnected, to get all these things sharing data and talking to each other online. So, where did this all come from? Well, the name Internet of Things was actually dreamed up way back in 1999 by a guy named Kevin Ashton. But the real game changer, the moment this went from just an idea to a reality, happened around 2008. That was the tipping point. For the very first time in history, there were more things connected to the internet than there were people on Earth. Think about that. And ever since that moment, the growth has been nothing short of explosive. I mean, just look at the scale of this. Back in 2003, we had fewer than one connected device per person. Fast forward to 2020, and that number jumped to an estimated 50 billion devices. That's insane. It averages out to more than 6.5 connected gadgets for every single man, woman, and child on the planet. All right, so that's the big picture. But how do we actually do it? How do you take a regular, everyday object and connect it to the internet? Well, it all starts with one fundamental step. You have to give that object senses. The ability to perceive the world around it. This is really the first piece of the puzzle. And that brings us to this idea of a smart object. This is like the basic Lego brick of the entire IoT. Every single one has four main parts. You've got a CPU, the brains, a power source, obviously, and a way to communicate. But the really crucial bits are the sensors, to take in information from the physical world, and something called actuators, which we'll get to in a bit, that let it interact with the world. Let's focus on those sensors. The easiest way to think about them is as the digital senses for our smart objects. They're the little bits of tech that measure real-world stuff. Temperature, motion, moisture, location, you name it. And what they do is convert that physical information into a digital signal, something a computer can actually understand. It's literally how we give machines the ability to see, hear, and feel what's going on around them. Okay, so now our object has senses. It can feel how hot it is or see if something's moving. Great. But that data is totally useless if it's stuck on the device, right? It needs to go somewhere. And that brings us to the next piece of the puzzle, connectivity. This is the internet in the Internet of Things. Now, here's the thing. There's no one-size-fits-all way to connect these devices. It's not like everything just uses Wi-Fi. Instead, there's this huge landscape of different wireless technologies, and we usually group them by range, basically how far they can shout. You've got short-range stuff for in your home, and then you've got long-range networks that can cover an entire city. Let me give you a few quick examples so this makes sense. For short-range things, think about your fitness tracker syncing to your phone. That's probably Bluetooth. For medium range, like all the smart devices in your house or sensors in a factory, you're usually looking at Wi-Fi. But for the really long-range stuff, like that smart farm we talked about, you need something bigger, like the 4G or 5G cellular network, or even specialized tech like LoRaWAN, which is awesome for sending tiny bits of data over huge distances. Okay, so we have billions of devices, all sensing things and all chattering away on these networks. This creates a brand new problem, right? A total data tsunami. It's just a massive, overwhelming flood of information. So how in the world do we make sense of it all? Well, that brings us to the IoT's digital brain. What's cool is that it's not just one big brain. It's more like a three-layered system. At the very bottom, right on the device itself, you have edge computing. Think of this as the system's reflexes. At the very top, you have the cloud. That's the super powerful central brain. And then, kind of floating in the middle, is fog computing, which acts like a local manager, sorting through data and only sending the important stuff up to the big boss in the cloud. And this whole structure is absolutely key to making the system work efficiently. I mean, think about it. The further data has to travel, say all the way from a sensor to a giant data center in the cloud, the longer it takes. That's what we call latency or delay. So by handling the really urgent, time-sensitive stuff right there at the edge, the whole system can react way, way faster. So you might be asking, why do you need both? Why not just use the cloud for everything? Well, it all comes down to a trade-off between speed and power. Edge computing is all about speed. It happens right there on the device, so you get super low latency for those split-second decisions. Absolutely critical for something like a self-driving car. The cloud, on the other hand, is all about raw power. It's where you do the heavy lifting, the big data analysis over the long term, like crunching all the numbers from our farm to see how the crops did over a whole season. All right, let's recap where we are. We've given our object senses, we've sent its data across a network, and we've processed that data to get a useful insight. But we're missing one last crucial piece of the puzzle. What do you do with that insight? This is all about closing the loop and actually having an effect on the real physical world. And this is where something called an actuator comes into play. If the sensors are the system's eyes and ears and the computing is its brain, then the actuators are the muscles. It's that simple. They get a digital command from the brain, and they perform a physical action. They're what opens a valve, turns a motor, or flips a light switch. And what you get is this really powerful feedback loop. The sensor measures the environment. The brain thinks about that measurement. The actuator does something to change the environment, and that action creates a brand new thing for the sensor to measure. It's just this constant, continuous cycle. Sense, think, act, over and over again. So, let's go all the way back to our farm and finally answer that question. How does it water itself? Well, a soil moisture sensor, that's the senses, collects data from the ground. The system, the brain, looks at that data and decides, hey, these crops are thirsty. Then it sends a command to an actuator, the muscles, which is hooked up to the irrigation system, and whoosh, it opens the valve. Simple as that. All without a farmer insight. So when you put it all together, you realize that this whole complex, amazing world of IoT is really built on just 4 fundamental pillars. These are the 4 building blocks. Number 1, sensing, to gather data from the real world. Number 2, connectivity, to send that data somewhere. Number 3, compute, to analyze the data and figure out what it means. And finally, number 4, actuation, to turn that digital insight into a real-world action. Every single IoT system you can think of is built on these 4 things. And that brings me to one last thought. After seeing all this incredible technology, the most shocking number might just be this one, 99%. What does that mean? Well, according to a lot of industry analysis, 99% of the physical objects in our world that could be connected to the internet still aren't. We're just scratching the surface. The IoT revolution has barely even started. So the big question I want to leave you with is, what will our world look like when that other 99% finally comes online?